Have you ever wondered if humans could grow food on Mars? It's a question that has piqued the curiosity of scientists, space enthusiasts, and dreamers alike. The concept of Martian agriculture is not just about farming in a new frontier, but it's fundamentally about our survival and self-sustainability in the vast expanse of space. We currently rely heavily on our home planet for food supplies. Every morsel of food consumed by astronauts aboard the International Space Station or during missions to the Moon has been shipped from Earth, a costly and unsustainable practice for longer space voyages. But what if we could change this? What if instead of shipping our food supplies from Earth, we could actually grow them on Mars? Imagine a future where astronauts cultivate their own food on the red planet, turning the inhospitable Martian landscape into a source of sustenance. Is Martian agriculture just science fiction, or could it be a reality? Let's delve deeper into the Martian farming conundrum. To understand if farming on Mars is feasible, we first need to understand the challenges. And believe me, there's no shortage of those when it comes to Martian agriculture. Firstly, we have to deal with the lack of liquid water. Mars is a dry, barren place. Although there's evidence of frozen water at the poles and just beneath the surface, liquid water is a scarcity. And as we all know, water is a fundamental ingredient for plant growth. Secondly, we have to contend with the extremely low temperatures. Mars is, on average, about 80 degrees Celsius colder than Earth. Most plants would simply freeze solid in such conditions, their cellular structures devastated. Next up, there's the thin Martian atmosphere. It's about 100 times less dense than Earth's and consists mostly of carbon dioxide, with only trace amounts of oxygen. These conditions are far from ideal for plants, as they rely on a rich supply of oxygen and nitrogen for their metabolic processes. And let's not forget the high levels of radiation. Mars lacks a global magnetic field and has a thin atmosphere, which means much more solar and cosmic radiation reaches the surface compared to Earth. This radiation can damage plant cells and inhibit growth. Now, if you're thinking that these challenges make Martian agriculture sound like a tall order, you're not wrong. The lack of liquid water, the freezing temperatures, the thin atmosphere, and the high radiation levels all pose significant hurdles. But what if I told you that none of these are deal breakers? That's right. These challenges may seem insurmountable, but scientists and engineers are working on innovative solutions. They're exploring the realms of hydroponics, aeroponics, genetic modifications, and even the possibility of utilizing Martian soil or regolith to support plant growth. But more on that in the next scene. For now, let's appreciate the complexity of the problem we are trying to solve. After all, we're talking about turning a cold, dry, radiation-blasted desert into a green-growing garden. No small task indeed. So how do we solve these challenges? Let's delve into the potential solutions. First and foremost, there's hydroponics and aeroponics. Hydroponics is a method of growing plants without soil, using mineral nutrient solutions in water. This could be a game changer on Mars, where the soil is lacking in essential nutrients. On the other hand, aeroponics allows for plant cultivation in an air or mist environment without the use of soil or any aggregate medium. Both methods could dramatically reduce the amount of water and space needed for crop cultivation, making them ideal for Martian agriculture. Then we have genetic modifications. Now, this might sound a bit science fiction-y, but it's really not. Scientists are already experimenting with genetically modifying plants to withstand harsh conditions. This could enable us to grow crops that can survive in the extreme Martian environment. Imagine a corn plant that thrives in the minus 60 degrees Celsius Martian nights, or a tomato that can bear fruit in the planet's thin atmosphere. It's not just a dream, it's a real possibility. And finally, we have the use of Martian soil or regolith. Mars is covered in a layer of dust and rock known as regolith that has potential for agriculture. Scientists believe that with a bit of tweaking, this regolith could be used to grow plants. This could involve adding bacteria to the soil that can fix nitrogen, a vital nutrient for plant growth, or using a process known as chemical gardening to extract water and other useful elements directly from the regolith. These potential solutions are not without their own challenges, of course. They will require significant investment, research, and testing, but they represent our best shot at overcoming the hurdles to Martian agriculture. And who knows, perhaps one day we'll be dining on Martian-grown vegetables, enjoying a salad that's truly out of this world. The future of Martian agriculture looks promising with these potential solutions. So could we really grow food on Mars? Let's summarize what we've learned. The Martian landscape presents a unique set of challenges for agriculture. Its thin atmosphere, harsh radiation, and sterile soil make traditional farming methods untenable. Yet these challenges are not insurmountable. Through the use of hydroponics and aeroponics, we can cultivate crops without soil, bypassing the problems with Martian regolith. Genetic modifications to plants can make them more resistant to the harsh conditions and even help them thrive. The importance of self-sustainability for long-term space missions cannot be overstated. We must develop means to produce food in situ, reducing our reliance on shipments from Earth. This is where Martian agriculture comes into play. The dream of Martian agriculture may not be so far-fetched. As we continue to innovate, the red planet may one day become our second home.